Hi guys, my name is Ganeshwaran Analalaki Segar. My matrix number is B0822104555. And today I'm going to talk about our assignment for electrical technology which was given by our lecturer Dr. Sahazati. This is the question we have taken for our assignment. As you can see, our circuit consists of AC input with voltage source and the value is 120 VRMS and the frequency is 60 Hz. On the other side, we have load, which Z equals to 10 plus J12. Okay, the next part I'll explain more about the impedance for our load. So the equation is Z equals to R plus JXL. And I've drawn a axis consists of X and Y. As you can see, X equals to real value and y equals to imaginary value, which is which converts to r as the x-axis and xl as the y-axis. After that, we have formula to find our power factor. So the step is to find the angle first, and for the formula for the angle is angle equals to tangent power of -1 imaginary part divided by real part, and we get the angle is 50.19. Now for the final step, we find power factor to know the efficiency of power in our circuit, and the formula for our power factor is cos angle, and we get the answer 0.642. This is our circle for this question. Now I'm going to demonstrate it in MATLAB. As you can see, we have voltage source, and to find the peak amplitude we have to times Vrms with square root of 2, and we get the value of 169.71, and for frequency it's 60 Hertz. After that, we have connected voltage measurement. To find that, we have to connect it parallel to our voltage source, and the output of our voltage measurement is connected to a scope. As you can see, this is showing a AC waveform. After that, we have a current measurement. To find current measurement, we have to connect it series to our circuit, and the output is going to another scope, which also shows a waveform of AC current. And as you can see, this is our load. We have used resistor and inductant in our load. Thank you.
Hello everyone, my name is Abhishek Chandalalaki Ramboven, metric number B11231010 and 1. So I'm sure my friend Dineshwaran has given you a general approach to this topic, which is a power factor correction. So now let's dive into a more detailed approach. So as you can see, this is our circuit. So we have a AC voltage source and a load. So what is power factor correction? So the main idea of power factor correction is to reduce the total current entering our circuit from the voltage source. So as you can see, this is before adding the capacitor, this is just a series circuit, which means we have a AC voltage source and impedance. So the total current entering our circuit from the AC voltage source is equals to total current entering the impedance. So we have to know what is the value of the current so that we can check later what is the current total current now entering. So IRMS is equals to VRMS divided by impedance following the Ohm's law. So the magnitude of the impedance we can get by square root r square plus imaginary square. So which is 10 square plus 12 square, square rooted we can get 15.62. So the current will be 120 divided by 15.62, which is 7.68 ampere. So the current coming from the voltage source is 7.68 ampere and entering load, which is 7.68 also. So as you can see, this impedance is in real and imaginary part. So we don't know which type of component they are using, which is going to help us when we are doing in the MATLAB. So previously, my friend already discussed about this, but let's dive more detailed into that. So if it's a capacitor, the imaginary part will be in negative because it will be in 1 over j omega c. So the j will be in negative value. But if it's a inductor, it will be just j omega l. So the imaginary part here is in positive, so that we can conclude that the real part is 10, which is 10 ohms for resistor, and the imaginary part is 12, which is the reactance for the inductor. So the inductor value we can obtain by omega L equals to 12, and divide the omega, we can get the inductor value. So the omega is equals to 2 pi f, which is 2 pi 60 from the question, 60 hertz. So we can take and substitute here, we can get 120 pi. So substitute here on the inductor part. So we can get 12 divided by 120 pi is equals to 31.83 millihenry. So now we can move to calculate the power factor. So this is a impedance triangle. So on this part, we have a resistor, this is the reactance, and this is the impedance. So our power factor is equals to cos phi, which means cos phi is equals to adjacent over hypotenuse. Following the triangle, the adjacent should be the resistor. Seeing from the perspective from the angle, the adjacent should be the resistor, and the hypotenuse will be the impedance. So impedance we already calculated, which is 15.62. So resistor is 10 from the question, 10, and here is the reactance, and the total impedance is 15.62 in magnitude. So 10 divided by 15.62, you can get the power factor. So as you can see, now we are going to calculate the real power, which is P equals to Vrms and Irms, which is the apparent power, and we have the cos phi, which is the power factor. So times everything, we will get 590.01 watt. We can also take only the Vrms and Irms to calculate the apparent power, which is 921.895 VA. So now we are moving to calculate the reactance. So as you can see, this is the power triangle. So to find out the reactance, we are going to take the value of power factor as well. So we are going to know the angle from cos phi. So cos phi previously we already know 0.64. So taking this cos and divide it, we can get cos power of -1, which is equals to angle 0.8763. So taking that angle, we are going to get the reactance value here, which means tangent phi is equals to opposite over adjacent. Opposite is our reactance and adjacent is our power. So previously we already know the power value and the angle value. So now we can substitute P into here. So which is reactance equals to power tangent phi. So 590.01 tangent 0.8763 will give you 708.3604 VAR. So this is our reactance. So now let's see the power triangle. So the phi1 and q1 is the old reactance, which consists of resistor and inductor. So now we are going to reduce the angle difference. So we are going to add a capacitor, which means the QC now. So the vector summation gives us a more reduced angle, which is phi2. So following here, when you reduce the angle, the power factor increases. Cos phi is equals to power factor. So cos phi is equals to 1 now. So phi we will get 0. So notice your angle difference when it's more to 0, the power factor will be more to 1. So in our question previously, they asked us to make the power factor into unity. So the cos should be, because cos phi is equals to 1, and the phi will be 0. So following this triangle again, tangent phi is equals to reactance. This is the new reactance divided by power. Power will not change because we are going to change the reactance only by adding a capacitor. So the active power will not change because of the resistor. So P tangent phi, so 590.01 tangent phi, tangent 0 is equals to 0. So following the power triangle from here, this is the Q initial. So Q initial is equals to Q capacitor and the new reactance. So now we can get the QC by substituting the values. So the Q initial was 708.3604 and minus 0, the capacitor reactance will be equal to the initial reactance. So now we can substitute the value into V2 RMS divided by the impedance, which is the reactance of the capacitor, to obtain the capacitance value, which is 130.49 microfarad. This was our previous MATLAB model. So I've modified into this model so that we can analyze the current total and also the power factor. So let's dive more closer. So now we have a AC voltage source which is giving a VRMS of 120, and the current going as we calculated was 7.68. So now the block has a load which is, so the active power we also calculated, which is 590.01, and the inductive reactive power is 708.3604 as we calculated. We can see that the power factor is equals to 0.64 as we calculated. So there is no specific block in MATLAB to calculate the power factor. So what I did was I took the power block from here and connect the voltage in parallel and taking the current from here as two inputs, and it will calculate me the power and also the reactance value. So now I took these two value into a function. So now as you can see, there is U1 and also U2. So there's nothing but the power value is equals to input 1, which is the U1, and the Q is input 2, which is the U2. So to calculate the power factor, we also have to see the power factor formula. The power factor is equals to real power divided by apparent power. So we don't have apparent power as our input here. We only have real power and also the reactive power. So now we are going to change the apparent power in the terms of real power and also reactive power. Following the power triangle, so S is in the hypotenuse, which means S we can be calculated by P square plus reactance square and square root, we can get the S. So we can take this formula and apply it into our MATLAB function. So U1 is our P divided by square root of U1 power of 2 plus U2 power of 2, which means power divided by square root power square plus uh, Q square. So now we are going to connect the capacitor. So this is our previous current and this is our previous power factor. So now let's run the simulation. So now as you can see, the current total drawn from the AC voltage source has been reduced and the power factor has reached to the unity power factor. So from this block, we can see that the capacitance reactive power is equals to 708.3604. From our calculation, the QC is also equals to Q initial, which is the Q load, previous Q load. So now the inductive reactive power was positive, and now we are adding a negative reactive power, which will cancel out and making our phase difference, which is the angle, to the zero, so that our power factor will be equals to 1. Thank you.